true.
I'll tell you the truth, but never goodbye.
Hey, Peter. Good morning.
Hey, good morning.
Hey, good morning.
Hey, yeah, thanks for having me. Excited to present this paper.
Yeah, absolutely. I'll give my quick walkthrough intro. So thanks everyone for coming to this week's Tory Tech Talk. Where Tory, we take an hour of work and complete it in 5 minutes for hotel sales agents. So that includes intake of new guests, replying to guests through AI and LLM processes, judging qualification, intent, performing research and analysis, personalizing offers, and getting conversion for hotels. And I don't know if Jason's oh no, Jason is on. Jason looks somewhat similar to Peter in my Slack.
I
So
think you were doing a great job with it. It was fun to see you roll roll with the
yeah, I
deck
was
for
thinking we
once.
should have one person in our team take turns every week, maybe.
Yeah, it's we'll make our interns do it, and that way we can we can test their knowledge of the key value proposition of what we're building.
Yeah, absolutely. So yeah, Tori is the world's first and fastest growing AI sales platform for hotels. You guys saw Jason, the most innovative man in hospitality, who's our CEO. And if anyone has any inquiries about media, press, internships, hotels, let us know. So Peter, you're presenting this paper, Tree of Thoughts, Deliberate Problem Solving with Large Language Models, and I'll let you take it from here. Would you like to share your screen as you look at the paper?
I see where you got my. I know where you got my photo from. It's yeah, that's funny. I laughed.
It's much better than your LinkedIn photo. So
Yeah, although yeah, I tend to disagree, but this is a great one as well in different ways. Yeah, I'll share my screen.
yep.
Can y'all see my screen?
Yep.
Cool, yeah. So I'll be presenting about Tree of Thoughts, deliberate problem solving with large language models. So they introduced this framework called Tree of Thoughts, which generalizes chain of thought, prompting large language models, and enables exploration over coherent units of thought, of text, which are thoughts, that serve as intermediary steps in problem solving. So it allows the LLMs to sort of think and plan like humans do. They're able to perform deliberate decision making by considering multiple different reasoning paths and self-evaluating choices to decide the next course of action. And then they also allow for look ahead and backtracking to make global decision choices.
Oh wow, the backtracking is pretty incredible.
Yeah, we'll see some nice
It allows
examples.
you to choose among a lot of options.
Yeah. So research on dual process models suggests that people have two modes in which they engage in decisions and thinking. This was introduced by Kahneman. There's a book, Thinking Fast and Slow, but so there's the fast automatic unconscious mode, system one, and the slow deliberate conscious mode, system two. And they say simple associative token level choices of LLMs are reminiscent of system one. They're sort of quick But there's no planning and thought involved. So for some tasks, you may need that sort of process, that sort of system two planning process that maintains and explores different avenues. Kind of if you're solving a math problem or doing any kind of planning in general, you may need to use essentially a tree-based approach. So they gave a nice illustration of various approaches to problem solving. So this is kind of a standard input-output prompting. You prompt the LLM with some kind of input, and you may create a wrapper around that question with few shot examples, or you might give it tasks. But then there's also chain of thought prompting, which we'll kind of discuss it, but essentially you allow for the LLM to kind of have thoughts, but they're very serial, so they build on top of one another. So you might have it make a plan and then act upon that plan, or have multiple different plans that are linked serially somehow. There's also called self-consistency with COT, which is essentially building multiple chains and then maybe voting on the best option. So you may have the LLM perform a given task in, say, 5 different ways, and within each of those 5, you have it kind of act serially and sort of perhaps refine its approach with thoughts. And then they introduced this tree of thought, which is essentially a tree of thoughts where in the first phase, you're allowed to have several thoughts. And then for each of these thoughts, in the next phase, you have it build the thoughts, and then so on and so forth for a predetermined number of levels. But here in this image also, they employ depth first search, and they value each state. So, and they truncate states which aren't promising. And we'll see examples of that, but maybe you go down this route, initially, and at this node, you value that you can't solve the problem, so you don't go any further. So then maybe you take the next best route. So this is kind of a depth first search approach where you go kind of down the most promising path until you either solve the problem or you can't, in which case you backtrack to your original position and then take the next best approach. So I guess we'll discuss that some more.
In B, C, and D, all the nodes are kind of handcrafted by a human. Is that correct? Or
yeah, that's a great point. Right. You sort of you get some results for a thought, and then you include these results and then prompt it with a future action. But you could also potentially do this in one step by giving kind of the rules ahead of time as well. But yeah, it's an interesting question. In general, you kind of want this to be sort of self-contained in that you sort of want the LLM to itself be able to plan in this way. But yeah, in this paper, sort of it's prompted with the output as well as kind of a layer on top of that. We'll see some examples, but yeah, that's a very interesting point. So to design planning process, we return to the origins of our artificial intelligence. They were inspired and explored by Newell, Shaw, and Simon in the 50s. So Newell and colleagues characterized problem solving as a search through combinatorial problem space represented as a tree. So they were inspired by this to propose tree of thoughts. And so TOT actively maintains a tree of thoughts where each thought is a coherent language sequence that serves as an intermediate step towards problem solving. Such a high-level semantic unit allows the LLM to self-evaluate the progress of different intermediate thoughts to make towards towards solving the problem through a deliberate reasoning process that's instantiated in language. And then as a last step, they combine the language-based capability to generate and evaluate diverse thoughts with search algorithms such as breadth-first search and depth-first search, which kind of give it a systematic way to explore with look ahead and backtracking, as we kind of discussed a bit.
So thought in journal is like the output from a step where we prompt an LLM and it gives something. So that's a thought for us?
Yes.
Okay.
Yes. Exactly. So we went through a bit of this, but input-output prompting, this is this first path, is we have some input or some question that we want, and they define it to be some prompting on top of this input. So we may wrap this input with a few shot examples or some type of rules. So that's what they define to be a prompt of an input. And then it's sort of a one shot, we get an output. So they define some symbols over that, but that's essentially the idea. And then chain of thought prompting, we also discussed, is to introduce chain of thoughts Z1 to Zn to bridge the input to the output, where each Zi is a coherent language sequence that serves as a meaningful step towards problem solving. For instance, Zi could be intermediate equation for math Q&A. It could also be sort of for creative writing, sort of a plan, and then so you might tell the LLM to give you a plan first, and then after that plan, for each of those plans to write kind of a story, or perhaps then you, for each of those plans, to kind of break it down further into sub-plans before you get the final story.
Check factual information.
Yeah, great point. And then self-consistency is just an ensemble approach. So you take independent chains. So you sample this K times. You do this K times, and then at the end, select the best via majority vote or some other mechanism. Yep, so coming down to tree of thoughts. A genuine problem-solving process involves the repeated use of available information to initiate exploration, which then in turn discloses more information until we find we're able to kind of attain a solution. And again, research on human problem solving suggests that people search through a combinatorial problem space, a tree where nodes represent partial solutions and branches correspond to operators that modify them. So here they highlight sort of the problems with the current, at that time, planning processes. In particular, if you think of COT, they don't explore different continuations within a thought process, the branches of the tree. So they might come down to a thought, but they don't explore different thoughts within that thought. So it was very sort of linear and serial. And globally, they don't incorporate any planning or look ahead or backtracking to help them evaluate different options. And it's It's kind of a heuristic guided search. It's sort of what we as humans would do, I suppose. We'd kind of evaluate the best options and then potentially be greedy and go down the route of the best options. So they define what's called a thought generator, and essentially give two ways of doing this. So you can prompt the LLM k separate times to give you k separate thoughts. So you could kind of run the same query k different times to get k different thoughts. They say this works better when the thought space is rich. So you can think of it in terms of like having the LLM write you a paragraph. Most likely, if you say the same thing to the LLM k times, it'll write k different paragraphs. You don't have to worry about collisions or it writing the same thing. But for shorter outputs, you may want to ask it sequentially to propose a prompt. What they mean by this is you could say, provide me k different answers for this question. Or you could say possibly, okay, give me another answer, where it uses the history, where it knows the history, and then it won't provide the same answer. So proposing different thought, they want to again propose different thoughts within the same context and avoid the duplication. This is really the goal, is to kind of avoid deduplication. And then you have, for each state or for each thought, you have a state evaluator. So the state is a thought. So it evaluates the progress made towards solving the problem. This could be a heuristic search algorithm, but they propose, I don't know if this was done before them, they propose using an LLM to deliberately reason about states. So you could ask the LLM, how good do you think this is? Or you could ask the LLM to classify. So this is what the value is. You could ask it to generate a scalar value. So how good is this from 1 to 10? Or a classification, how are we sure, likely, or impossible to reach the final state given where we are currently? Now, again, such evaluations don't need to be perfect. They only need to be approximately helpful for decision making. But again, the novel, maybe the idea was there already, but the idea is to use the LLM to value its states, which is kind of interesting. And then you could also vote across states. So this is similar to the self-consistency. So you could cast it as which state to explore, which is your best option. You could actually sample. You could use LLMs to sample votes for it. So you can prompt the LLM multiple times.
Jason's asking if the QR code is posted anywhere.
I'm sorry?
Jason's asking if Jason, what QR code? Oh, sorry. I can mark you a checked in. Sorry, I misunderstood what he was asking.
Oh, okay. Cool. Yeah, so you could prompt the LLM multiple times to vote for the best result. Which I guess yeah, I suppose you want some diversity in that in thought. So it's interesting how to kind of get that diversity. Yeah, how you kind of get that diversity in thought. But so So then they also you kind of use search algorithms, the breadth first search and the depth first search. So you could get a level of thought. Say you're at the first level, and then you could value each of those states and prune them to the 5 best states. And this is what they're calling breadth first search. And then you could repeat this as well. So you're constantly you're pruning at each level. And then depth first search explores the most promising state first until the final output is reached, or the state evaluator deems it impossible to solve the problem from the current state. And then we prune and backtrack to the parent state, in that case for continuous exploration. And here they're just kind of summarizing the impact of TOT, which is that it generalizes these previous methods. So there's modularity. These can kind of all be varied independently. It's adaptable to many different problems, and it's convenient in that you don't have to retrain an LLM specifically for this, although you might want to. Maybe you'll have better performance if you do for certain problems, but ideally you don't want to. And then we get into several experiments. So there's 4 different problems they look to solve with this. Number 1, the game of 24, creative writing, and then 5x5 crossword. So the game of 24 is a mathematical reasoning challenge where the goal is to use 4 numbers in basic arithmetic operations, plus, minus, multiplication, division, to obtain 24. So how can you combine the 4 input numbers with these signs to obtain? Can you do that to obtain 24? That's the question. So if this was the input, this is the input for 9, 10, and 13. Could you combine that in any way with these symbols, the standard symbols, to obtain 24? In this case, you can. 10 minus 4, which is 6, times 4 is 24. And how do they go about solving this? They have kind of a proposed prompt where they ask the LLM to propose, given an input, propose the next steps. I suppose they prompt it also with the goal of obtaining eventually 24. So maybe they give it some few shot examples as well. But in this case, one thought would be 10 minus 4. Another thought would be 4 plus 9. And then once it, I believe they use breadth first search, so they vote on and select the 5 best candidates, or they have versions for 1 and also 5. So say the 1 version where you choose the best candidate and proceed.
How are
that would be this candidate.
When there's a terminal state? I guess that thought evaluation, like they have impossible shaded red.
Yeah, they could be wrong. They could be wrong and not solve and kind of provide a wrong answer. But in this case, when they come down here, 4 times 6 is 24. So they would provide this solution and hopefully be right that 4 times 6 is 24. But they could be wrong as well. They could make mistakes along the way and not be able to solve for a certain input.
Well, I guess no, my question is more along the lines of how are they judging that they've reached a terminal state?
Yeah, so I believe all you need is 3 levels for this, if I'm not wrong. because it's sort of like the left, the right, and then the combination of the two. So in this final state, yeah, do you get 24? Is propose a thought. You're given 4 and 6 as your input. Can you combine that in some way to get 24? So the thought would be to use multiplication. This is one thought.
Well, I
Another
guess,
thought would
is
be,
is there some sort of like classifier going on? You know, is there something that looks at the text in that thought evaluation block and says, this is a terminal state, stop? Or
they use, I believe they use the LLM to evaluate itself. So like, does 4 times 6 equal 24?
Yeah.
Does 4 plus 6, can you get to 24 from 4 plus 6? No, you can't. So it's terminated. This is the thought is 4 times 6 here. So they just ask the LLM, does it equal 24? If so, output the solution. But it could say no and be wrong as well. In which case, I guess it's wrong. I don't know how good LLMs are with mathematics, but I think they're pretty decent with basic sort of arithmetic operations. Yeah, but
Yeah, there was what, there's 6 possible first steps that you can make with a set of 2 numbers and 4 operators, because multiplication and addition are transitive.
yeah, but in this case, you have 4 numbers, so I think there's more.
Right, but you have, but so you, right,
Oh.
so was it taking all number pairs, in which, you know, I guess
Yeah.
this seems like a very, this seems like
I'm
an
not
example of
sure how
something-
many
Yeah,
they're initially choosing, but they are pruning to 5 or 1.
they were, okay.
Yeah, but yeah, it's a good question as to how many initial thoughts they have. Yeah.
But right,
But-
and I know there are more than 2 numbers, but you have to start with the operation between 2 numbers. So
Yeah.
you could arbitrarily pick 2, and order should not matter, because it looks like the parentheticals you can kind of just place anywhere. I don't know,
Yeah.
it's interesting, right?
Yeah, I guess it's, yeah, 4. Yeah, I guess.
Yeah, this is
4,
interesting
2,
because it seems
2,
very
and-
solvable.
Yeah, you could solve it with kind of, yeah,
Well, I mean, I think that goes without saying, you know, this is something you could do in classical data science. I mean, classical.
Right, exactly. I don't know why we would have an LLM do it, in
It's
some
a
ways.
generalizable example. I think it's really cool because I used to think it was kind of an amusing example if you ask a LLM, you know, an arithmetic question that just nobody has already done on the internet before, but like a human could do in 5 seconds, that it would, you know, clearly not be able to get the correct answer. But here it's kind of solving for that, so it can generalize
Right, but I think what's interesting, right, is you pointed out that if you turn it into like classical machine learning, then it is something that an algorithm could handle pretty well. We're making an LLM act more like an algorithm through TOT.
yeah.
Which is interesting, right?
but it's coming up with the
Math is,
key part there.
well, I don't know, I can't see what the prompts are. Possible next steps, yeah, I don't know. Right, you could have said, take 2 number pairs, you know, select 2 numbers. Try the 6 possible arithmetic, you know, operations between the 2 of them. And if that's your prompt, you've turned it into kind of you know, an algorithm, just using natural language to direct it.
Yeah, and I guess maybe the LLM could kind of make good guesses, I suppose. Because yeah, if the initial choices are all possible, you know, choices, then
Right. But this is like how a chess engine works, right?
the state space, I suppose. Yeah.
Yeah. It just throws a ton of compute at like all possible trees of outcomes based on next move. And it tries to cut down on them based on probability that I don't know. I'm not exactly sure how a chess engine works. That's my understanding of it.
Yeah,
Yeah.
they used to work like that. In the olden days, it used to be very much like a
You're
tree-based
gonna give me
approach of
some
trying to solve. Um,
zero, alpha zero.
yeah, Alpha Zero
Yeah.
does not work that way as far
No,
as I
I know
understand.
it's
Yeah,
super cool. Alpha zero like
yeah,
trained
yeah.
itself on chess.
Yeah, I think when you actually have like an objective function like that, right? Like in chess, there's a way to win or lose, and so you can train these models much more easily, in my opinion, because it's, with the truth is not something that is definable really. And unless you're talking about these extremely like simplified little like math problems, so I don't know how, like, it seems like it would be hard to train an LLM to be more truthful, in the same way that it's like easy to train an LLM to be more good at chess, just because one thing is so well defined, whereas, again, unless you have something like
What?
this where the problem is
Yeah.
so well defined that it almost seems like, you shouldn't use an LLM to solve it, then it's hard to define what truth is basically my main point, I guess, as opposed to chess.
I suspect an LLM could be trained to be very good at chess because you could turn it into written notation and just predict like next moves, right?
Yeah, but all it's doing then is predicting the next move, right? It's not predicting the best next move.
Yeah, but
So you either show it,
train it on just on Gary Kasparov and see how it does, right? Like,
yeah,
yeah,
you could do that, but Alpha Zero is trained like basically playing itself and updating
right.
this like profile by doing that, and that like just allows you to go so much faster because you don't run out of data, So I feel like there's just this thing, right? Like I watched a really interesting video about this that Numberphile put out recently about generative versus like classification models. So when you're trying to generate something, it's really, really open-ended, right? So you need so much data to actually capture every possibility and, actually be right. But when you're trying to classify something, you're trying like, you're fitting stuff into a like a hole, right? Like you're trying to say, okay, this is a cat or this isn't a cat. There, the amount of data that it takes to just make that binary decision, it's like exponentially less, right? So like I think there's a reason why they didn't train Alpha Zero with just GPT, like showing it a bunch of text, and it's probably
Right.
because there isn't enough data, right? If you get it to play itself, then it's more games than humans could ever play, like in a million years that you're showing it, and then there's also that idea of like this is actually good, which is hard to do with these generative models. Instead of, because I feel like these generative models, they're just like this is what's next, not this is what's good or what's right. So
Well,
yeah,
but that's what this TOT is attempting to do, right? Say
yeah,
this is
yeah,
what's
yeah.
good. This is a more correct answer.
Definitely. Yeah, it's definitely like a way to do that for sure. I just think in general the way these models are trained, right? It's predict the next token, right? It's
Yeah,
not
no, no.
predict the correct token. So that's like just the main I don't know, the main like the main thing with these models is it's just really hard, in like some of these complex use cases, even what truth is hard to define, like I said. So but
Well,
this would be, probably
it's
improve a
almost
lot
like
on a lot of outputs.
this is almost like a recurrent neural network, right? So you would kind of back propagate through all of that at the end of your chess move or chess game, I guess. Does that make sense, Greg?
Um, yeah, I think
I mean,
the thing basically the issue here is that you're not really like it basically like if you just had a bunch of labeled data pairs to solve this problem, right? Like you could try to train a machine learning model to do it. Um, and then you would actually have the classic like feedback that you get in machine learning where the weights are updating based on the predictions. So like by doing something like this, you're not doing that exactly. You're more, just playing with the outputs of the existing model, right? Like you're not actually able to update the weights at this point in the training,
yeah,
unless you do fine tuning, but that's a different thing. But I think like it's still, if the results are better than the baseline, right? There clearly is something there in terms of actually using these models this way, right? Like, and yeah, for some problems, like, yeah, for this problem, right? If your business relied on you having to add 4 numbers to 24, then maybe don't use LLM with tree of thoughts, because that's not like exactly, you know, the best way to do this specific problem. But for stuff that isn't as well defined, you know, I could see it like, again, it's just hard to define how much better it is, which is like a problem that I have in general with evaluating these things. But I could imagine that it could be better, you know, it could be much better. It's just about, you know, how do you actually go and say, like, in Tori's example, in 1,000 emails, like, all of these responses were better from this model or more correct, or, you know, that's the part where it's kind of hard to like evaluate that. I don't know. That's where a lot of questions for me come up. But I do think that this, you know, it looks like a really interesting approach.
Yeah, I think
I
everybody,
wonder.
and especially the authors of the paper, would agree that game of character is not an intended use of what they're doing here. It just
No,
but
but I wonder what Red brings up, which is the answer is that actually for evaluation purposes, LLMs may be poorly suited for the evaluation technique, and it may be more the generative tool. And you say, listen, here's 10. This is a great opportunity for reinforcement learning with human feedback. You know, ask a user to select one, and then ask it to follow the same path of, you know, thought that led to that created outcome, right? Because these are subjective, you know, when you're talking about like quality of an email or quality of a response, those are subjective designations that, like, maybe the world's language collapsed into a very average predictive model is, you know, is not the best at evaluating the quality of the response. Is that a fair way to like think about what Red's pointing out?
oh yeah, I think that we've said that for weeks, that it's pretty hard for the LLMs to judge the quality of LLM outputs. But classification is kind of a different task, I think. But
Well, no, but earlier in this, the idea was something like, hey, rate this on this response on 1 to 10, right? And asking that as kind of your guiding technique to different branches of the tree.
well, maybe I was being too general with my comment. I mean, you know, if judging is a form of classification, so if I'm saying, if you're judging it based on, if the classification, or let's make it more regression, if you're doing a regression on how eloquent is this text, 0 to 100, maybe there
Sure.
can be a lot of variability there, but something,
I think I'd just be more comfortable with like applying one of those like reading models, right? Like there's like things that judge whether or not something reads clearly, right? And
yeah,
that's an
but I
algorithm.
think my ultimate point
Like,
is what's the fundamental difference between that and this model? They're both
Because
theoretical.
there's an objective scoring standard, and
Oh, you're
LLMs are random.
heuristic, not a.
I'm sorry.
You're referring to a heuristic.
Yeah, no, there are like what grade level is this written at, right? And there are models that, you know, have a library of or a dictionary of words, and then it says, okay, you wouldn't use these words if you weren't in this grade level. There's like measures of reading, like clarity and readability scores. Using something like that to judge the output, combining kind of traditional algorithmic evaluation, or it seems to me, I don't know. It's like we're very eager, and I don't know. I'm sounding like Red here, maybe not, and but like we're very eager to use LLMs to like judge LLMs, and like model collapse is a real problem. And like, sure, it'll work when you do something like, can you objectively get to 24? But you know, so much of the evaluation is happening at an LLM level too. That I don't know. I wonder whether that's sustainable. Whether we need to combine.
Yeah, I think it's, you know, trying to have it sort of trying to get to the point of being an all-encompassing model that can solve any kind of high-level solution, right?
Right.
And I don't think it's there yet, but it's kind of trying to think like, how would I solve this as a human, and then try to kind of bring that into LLM language.
But isn't it more likely that it would just ingest somebody's, you know, human work or like human created algorithm and use that as an evaluation technique. Like that's kind of what
Maybe,
LLMs train
yeah.
on.
I mean, maybe if it if it gets to that level, yeah, it should kind of eventually decide on what approach is the best to
Right.
solve this
So maybe
problem.
it can
But
identify the best
yeah, early on,
heuristic or
right,
algorithmic
right,
model.
yeah.
That's interesting, right? I don't know. It's just
You
you're
also
training
get
on like it's
data, it should be you should be able to have it match the performance of these rougher heuristics you have, like what grade level is someone reading at?
Mhm.
I don't know. I'm skeptical that that's a rougher heuristic. And maybe I'm just like biased
Yeah, well, I know
toward
there's numbers that are used, like basically when laws are passed, the language has to essentially, there's a metric
yeah.
that's used based on, the variety of the words and how long they are and that sort of stuff to kind of capture the simplicity, and it's pretty robust. But there's obviously there's no the space is just so vague, right? Like of like what is good or bad, and you have so much room for error where it's like you could use one adjective instead of another, and it would actually still be like qualitatively pretty much the same, right? But those are technically two different sentences, two different outputs, and I guess basically, you know, I think that just like what's missing from a lot of these like papers, I think, is almost like a more fundamental kind of discussion of what is knowledge and what is truth. And I don't want to get too philosophical here, but basically like in math, there's this thing called the incompleteness theorem, which tells you, even if you were like some sort of perfect computer that was able to combine like all like logic and previous true statements in math, there are still statements that are true that you can't prove from the existing like things that are true. So there's things that are just unprovable, but they are true. And uh basically there's just like this whole, people have thought really deeply about, okay, when you put together a system where you say like if this then that, and then you just make it like more and more complicated, eventually what happens, and are you able to keep it consistent? And you're not. Like even within math there's like really high level debates basically about, oh, this rule should not be introduced because it leads to this weird phenomenon over here in math, right? And so it's like the just pursuit of like, just truth and getting stuff right like this is just like so weird to me in a way, because there's certain things where it's like, man, the like actual truth is such a complicated thing, of what actually is true out there. And like I guess the way humans solve problems, honestly, it's gotten us pretty far, right? So that's great. But I also think that that at the
programmed
same
yeah.
time, like
Yeah.
there's just this like there's something like fundamentally like that is just like something about solvability, I think is somewhat missing in here somehow, or and just like this more like just different consideration of what truth is, because I haven't seen anyone really define it. Like again, this example is like actually probably the best example with the 4 numbers 24. But in so many applicable use cases, it's so hard to say like this is true, this is false, and there's multiple narratives that people are trying to spin, and like multiple things can be true at the same time. And I don't know, I'm just like when I start thinking about this and like and thinking about it truly generally, then I kind of like start going nowhere, And I think maybe it's just like, me in my own head just building it up like too much and not like thinking like it's too big of a problem to solve. I don't know. But what I will say is like uh basically like at some point, reinforcement learning with the human feedback was brought up with these kinds of tree of thought models, but like my caveat there is basically like you have to look at the feature space that you're in, essentially like how many possibilities are there, how many roads can I go down, essentially. And if the number of roads is really really large, then you need an extremely large amount of data to be able to train the model to tell it which one to go down. So that's why like self-driving cars haven't worked yet, basically, at least like not like fully autonomous the way people were promising way back in the day, is because they don't have a way to actually understand rules. It's basically just like they see all of these camera inputs and pedal inputs and stuff like that, and then they see like the outputs that the human makes with a steering wheel, and they're just trying to tie that together. But there's just too many roads, there's too many scenarios, there's just too many edge cases basically for the model to actually learn what to do all the time. And so like with this tree of thoughts thing, right? Like if you could try to say, hey, this is the best thought, this is the best thought, but because the space of thoughts grows so much, the amount of data that you would need to actually like do that properly would probably be, insanely massive. So yeah, it's hard to, I think, yeah, at the end of the day with these things, right, like they're using the LLMs to evaluate the LLMs because at a certain point, the amount of text that's being created and stuff, it's just too much for a human, right? So I think that's part of it too. But yeah, I just went on a bit of a rant there. Sorry to hijack, but it's a great paper. So thank you.
That good
No, it's super interesting.
incompleteness theorem has finally been touched upon at these tech talks. Yeah, I mean, but aren't you just reinventing reinforcement learning at the end of the day here, but using the LLM to, generate the data, to evaluate actions, to evaluate values?
I don't know if there's any reinforcement going on. That's the thing. It's
Yeah, I mean, I feel like we went way off topic there, but
yeah, for this in particular. But yeah. Well, let me get to the last two games, and then
I appreciate the discussion.
yeah, no, it was great. It's really awesome. So this one is more kind of a standard LLM type problem, but basically you want to create a coherent passage of 4 paragraphs. Not sure about this part that end in the 4 input sentences respectively. I think maybe I missed that part when I was reading it earlier, but essentially they solve it with kind of a standard planning process where they have the LLM generate 5 plans, and then they vote on the best plan, and then they provide say 5 passages from that plan. They sample 5 passages from that plan, and then they vote again on the best passage.
Caught him off guard that the space smelled of seared steak. What a great sentence.
Yeah. Yeah. Is it somewhere up here? I guess I missed that sentence. I guess.
It's right in the input A,
Oh, input A. Okay.
the second one.
Oh, the second one. Okay. Yeah. Okay.
That is a random
Oh, so
sentence.
I see. So yeah. So the end sentences of each paragraph have to end with each of these. Okay, I missed that part when I was reading it earlier. So each of the 4 paragraphs have to end with these sentences. Got it. Yeah, so this is an example of another type of BFS approach where they're kind of voting on the best, or maybe you could choose like the top 2 and then create passages out of that, and then vote. They do add that with iterative refinement, they could perform even better, where instead of generating new thoughts, if you could refine your old thoughts, then you could perform even better. And then the final game is the mini crossword, where essentially you want the LLM to solve a crossword. And this is very much a depth-first search type problem, where right, you take a guess at a word, and then assuming that word's true, you use that information to further further choose other possible clues and fill in sort of the blanks in sort of a very depth-first way. So in this case, salon doesn't work. So this subtree is pruned. So they go to grand, and then they make the assumption H3 is grand, and then proceed from there. And then, right, in sort of the next level of the tree, they provide that thought, or that they prompt it with the information that exists out there so far. So if grand was the assumption, then that goes into the as input to the next thought. And then they rank their thoughts based on most likely, sure, impossible, maybe, and then they kind of go down the ones they're sure about. So this is a state evaluator over each clue. So they rank their clues rather, and then they go down the route of, and I suppose they rank the choices they make as well, perhaps. Also filling the remaining word clue, yeah, and then they kind of prune, and hope to get to a correct solution. I believe they showed that they were able to solve 20% of the games, so by far much greater than COT and IO. But this is a very sort of depth first search type problem. And for depth first search, you really need kind of a wider tree. So it makes sense that this kind of would work the best. But yeah, this is the paper, and I hope you enjoyed listening to it. But that's pretty much all I have. I don't know if there's any comments or questions. I think we had a nice discussion earlier.
Yeah.
Yeah, thanks, Peter. I'll take back over and just share the next couple papers we have being presented. Addison, you're presenting next week, if you're still on. Yeah, do you want to give it a very quick what that paper's about?
Yeah, so this paper, Tori, we use kind of a lot of RAG. Obviously, being able to retrieve kind of customer data and be able to present that is very important. What we're doing, and I imagine it's probably semi-important for what a lot of other people on this call are doing. But there are definitely times when you do want to do it and when you don't want to do it, and also the ways in which you do go about kind of this making these retrievals is very important. And so this paper will kind of explore, okay, well, how do we ensure that we're not retrieving the wrong things, and how do we ensure that we're not retrieving stuff when a user is just asking something that's very simple, which our LLM could solve almost immediately, to kind of cut down on costs and also not to kind of introduce noise into our prompts.
Yeah, very exciting. I'm also very interested on our team kind of moving to the next step of what was discussed earlier in regards to getting some chain of thought.
Yeah.
So that's pretty exciting. So
yeah, Peter, a very, very timely paper, and we appreciate it because we've been
picked this paper,
talking about it
so
around the office on Chain of Thought this week.
Oh, that's great. That's great.
But no, it's really, really interesting to see the types of. It seems evident to me that some of the things that we're working on trying to solve with Chain of Thought are super, super relevant. And prompting to make lists, make comparison. Is anything within the list mutually exclusive? Those types of questions are great for an LLM, and so this was really timely for us, and I appreciate that, and thought you did a great, awesome job, like kind of summarizing what was like some really complex things going on. So thank you.
Oh, great. Yeah. Yeah, glad to hear, and yeah, happy to share and read the paper. It was a nice read for me as well. So thank you guys.
Yeah, thanks so much for presenting. This was fun.
Yeah, this is a fun one.
Yeah, thanks for the discussion as well. That was great.
Take care, everyone. Appreciate it.
Really, but
Thank you guys.